Deep inside this massive industrial zone stands a colossal facility, redefining how we view agricultural waste. This mega factory takes millions of discarded banana stems and transforms them into incredibly strong natural fibers. What was once considered useless garbage is now the raw material for a sustainable textile revolution. Inside, a labyrinth of advanced robotics and automated systems work in perfect harmony to process biomass. The banana pseudostem is actually layers of tightly packed sheaths hiding a treasure trove of fiber.
Before we peel back the layers of this technology, click subscribe for more industrial megatours.
The process begins in the field, where plants are cut down immediately after the fruit harvest. Specialized automated loaders collect the heavy trunks, ensuring they remain clean and undamaged for transport today.
Upon arrival, the stems are dumped into a water flume to wash away dirt and debris.
High-pressure water jets blast the outer surface, removing soil that could damage the sensitive precision machinery.
Advanced laser scanners measure every single stem, sorting them by diameter to optimize the extraction settings.
The massive trunks enter a hydraulic splitting machine, slicing them into long, manageable strips for processing.
This automated tuxing process peels the individual sheaths from the core, separating the layers by quality.
Outer green layers produce coarse fibers, while the inner white layers yield the finest, silk-like strands.
The strips are fed into the decorticator, a beast of a machine designed to crush biomass. Inside, rapidly spinning blades scrape away the fleshy pulp and water, leaving only the tough fibers. The waste pulp is ejected below, collected to be converted into organic fertilizer or biogas fuel. Emerging from the other side are long, wet strands of raw fiber, stripped of all pulp. Robotic claws snatch the wet bundles and hang them on an overhead rail for immediate washing.
They pass through a washing tunnel, where high-pressure jets remove the sticky, natural sap and sugars.
Removing the sap is crucial, as it prevents the fibers from browning or rotting during drying. Next, the fibers are dipped into a bioenzyme bath to soften the cellulose and improve texture. Technicians monitor the chemical balance precisely, ensuring the fibers become soft without losing their tensile strength. To save energy later, the wet fibers are spun in a giant centrifuge to remove water.
This mechanical dewatering process removes 80% of the moisture before the thermal drying stage begins.
The fibers then enter a massive thermal drying tunnel, where hot air circulates to finish drying.
Sensors maintain a consistent temperature, ensuring the fibers dry evenly without becoming brittle or heat damaged. What exits the tunnel is a transformation. Fluffy, golden white fibers that look remarkably like coarse wool. Automated brushing machines now comb through the strands, aligning the fibers and removing any remaining pulp. Powerful vacuum hoods suck away the dust and short fibers, which are recycled into paper products. Robotic arms weigh and bundle the cleaned fiber, preparing it for the next stage of grading.
Optical scanners inspect every bundle for color consistency and density, rejecting any that fall below standards.
The fibers are sorted into grades. Grade A goes to textiles, while Grade B goes to handicrafts.
Textile-grade fiber enters a softening machine, where rollers break down the stiffness to mimic cotton texture.
The result is a silky, flexible material that can be spun into yarn, just like cotton.
The material moves to the carding machine, which combs the fibers into a continuous, thin web. This web is condensed into a thick, continuous rope called a sliver, ready for the spinning frames. Rows of high-speed spinning frames twist the sliver, thinning it out into strong, durable yarn. Bobbins. These bobbins fill rapidly with banana yarn, a sustainable alternative that is stronger than conventional. Unlike cotton, banana fiber has a natural sheen and high tensile strength, making it highly desirable. The bobbins are loaded onto massive industrial looms, where the magic of weaving fabric truly begins. Shuttles fly back and forth at blurring speeds, interlacing the banana yarn into sheets of fabric. The resulting textile resembles linen or hemp, breathable and perfect for high-end, sustainable fashion brands. In the dyeing house, the fabric absorbs natural dyes easily, reducing the need for harsh chemicals.
But textiles are not the only output. The lower-grade fibers are sent to the paper section.
Coarse fibers are boiled in large digesters to break them down into a thick pulp.
Giant rollers press the pulp into sheets, creating heavy-duty paper that is stronger than wood pulp. This paper is used for everything from tear-resistant tea bags to currency notes and heavy packaging.
In the molding section, machines press the pulp into biodegradable plates and bowls for food service. These eco-friendly products decompose in 60 days, offering a powerful alternative to single-use plastic pollution.
Even the liquid sap collected earlier is processed into a nutrient-rich, organic liquid fertilizer concentrate.
Bottled and sold to farmers, this liquid gold returns vital nutrients back to the soil naturally. The factory is nearly self-sufficient, burning the dried central pith waste to generate its own electricity. This biomass energy system ensures the facility has a near-zero carbon footprint, a manufacturing miracle. Back in the lab, technicians stretch the yarn to its breaking point to ensure global standards. Advanced AI monitors every metric, constantly optimizing the line to squeeze value from every stem. The finished rolls of fabric are stored in a massive warehouse, ready for export worldwide. From here, the material travels to high-end fashion houses in Europe, Japan, and the United States. It ends up on the runway, a sustainable luxury fabric that started as waste in a field.
It is even entering the automotive industry, used to create lightweight, eco-friendly dashboard panels and composites.
As the shift ends, the machines are cleaned, maintained, and prepped for another day of production.
Outside, the banana plants continue to grow, providing an endless, renewable supply for this green giant.
Local farmers now have a second stream of income, paid for waste they used to burn.
This factory proves that environmental responsibility and industrial profitability can coexist on a massive scale.
From a discarded stem to a luxury product, the transformation is a triumph of modern engineering. Innovations continue, with absorbent banana fiber now being used for sustainable, biodegradable sanitary products worldwide.
Researchers here are even experimenting with nanotechnology to make the fibers fire-resistant and antibacterial naturally.
The porous nature of the fiber makes it an excellent material for filtering heavy metals from water.
In construction, banana fibers are mixed into concrete to reduce cracking and improve overall structural durability.
This facility is just the beginning, a blueprint for a future where agriculture produces zero waste.
Plans are already underway to replicate this high-tech model in other banana-producing nations across the globe. It is a literal case of turning trash into treasure, revitalizing rural economies in the process. Automation keeps the costs down, making banana fiber competitive with cheap, polluting synthetic alternatives like polyester.
Unlike synthetics, these fibers burn clean and decompose naturally, leaving no microplastics in our oceans.
The environmental impact extends far beyond the factory walls, protecting ecosystems from plastic waste accumulation. As night falls, the logistics fleet rolls out, carrying the sustainable materials of tomorrow to market.
The factory glows in the darkness, a beacon of innovation in the heart of the tropics.
Shift changes are seamless, ensuring the heartbeat of this industrial giant never skips a single beat. From rugged floor mats to delicate silk-like scarves, the versatility of this plant is truly unmatched. It also supports traditional artisans, providing high-quality raw materials for the handicraft and cottage industries.
Safety systems are state-of-the-art, protecting the flammable fibers from the risk of industrial fires.
Worker safety is paramount, with strict protocols and protective gear mandatory for every person on the floor. Every ton of banana fiber produced offsets massive amounts of carbon dioxide compared to synthetic production.
If you are fascinated by this process, don't forget to hit subscribe and ring the bell.
It is clean, white, strong, and ready to weave the fabric of a sustainable future. This facility is more than a factory. It is a vision of a waste-free world. Driven by human ingenuity and powered by nature, the banana stem industry is here to stay. So the next time you peel a banana, remember the incredible potential hidden in the stem. We leave this industrial marvel now, having witnessed the transformation of nature through high-tech engineering. Zero waste, 100% sustainable, a model for the future of global manufacturing standards. It starts with a truck, but it ends with a solution to some of our biggest problems.
Tougher than wood paper and kinder to the planet, the applications are limited only by imagination.
Designers and engineers are finding new uses daily, pushing the demand for this factory's output higher.
The belts never stop, a continuous river of fiber flowing to meet the needs of the world.
Overseeing it all, a management team dedicated to efficiency, quality, and ecological stewardship every day. Click the video on your screen to explore another mega factory that is changing the world.
Join our community of curious minds and discover the hidden world of industrial manufacturing with us.
Thank you for watching, and stay tuned for our next deep dive into industrial technology.
From the field to the factory, this is the story of the humble banana stem.
See you in the next video.